Continuing in Chapter 3, we are now looking at Section 3.5, and we're looking at multiplying radicals. So, when you have two radicals and you're multiplying them, you can do it a couple different ways. You can simplify first and then multiply, or you can multiply and then simplify. So in this example, the square root of 4 is 2, and the square root of 25 is 5, and 2 times 5 is 10. So that would be simplifying and then multiplying. And here it makes sense because they were both perfect squares. The other way to do it is to just multiply them first. 4 times 25 is 100, so we have the square root of 100, which obviously also equals 10. So sometimes, like in this case, where these are perfect squares, it would make sense to do it this way. But if they're not perfect squares and they can't really be simplified, or they can be simplified but there's still going to be a radical left, sometimes it makes it easier to multiply first and then take the square root. So let's look at the second example. You might want to simplify the radicals first, like the square root of 18 can be broken down. But if you look at this, you'll have an a that comes to the outside here, one that stays in. So in this case, it might be easier to multiply first and then simplify. Or if you don't want to multiply it out, like you don't want to multiply 6 times 18, because we're going to ultimately simplify, break them down. So 6 is 2 and 3. 18 is 9 and 2. Remember how we previously said you can break it down into either prime numbers or perfect squares. And then we have a to the 4th. So then you get the square root of 9. Take care of that. Square root of 9 is 3. Square root of 2 times 2 is just 2. 3 is left over, so it stays in. A to the 4th, the square root of a to the 4th is a squared. And then just simplify your 2 times your 3. So 6a squared square root 3. In the next example, we're going to use the distributive property. So remember the distributive property, you take what's on the outside and multiply it by everything inside the parentheses. Square root of 3 times 2 is 2 square roots of 3. Square root of 3 times square root of 3 is just 3. Square root of 9, or just 3. And then the final thing that we can do with multiplying is foiling the distributive property twice. So if we have a binomial times a binomial, we take the first thing and distribute it to everything in the parentheses. Then we take the second thing and distribute it to everything in the second set of parentheses. So we get 2 times 1, 2 times the square root of 5, square root of 5 times 1, square root of 5 times square root of 5, which is just 5. Combining like terms, we have 2 plus 5, which is 7. We have 2 square roots of 5 plus 1 more, or 3 square roots of 5. So multiplication is generally easier than adding and subtracting. Again, simplify, then multiply, multiply, then simplify, distributive property, FOIL, or distributive property twice. Okay, let's go to the next page and talk about division. So remember we talked about how we can separate, we can have it under one radical, or we can separate it under two. Sometimes, like in this case, it makes sense to separate them because the square root of 4 is a perfect square. And sometimes it makes sense to write it under one radical because 8 divided by 2 comes out to be 4, and that's easier to simplify. So just remember that you can always write it under 1, break it down to 2, or if you have it under 1, break it down to 2. If you have it under 2, you can put it under 1. Next page. So let's do a little practice. When I look at this, you could simplify the square root of 27, but when I look at 27 and 3, I know that 27 divided by 3 is 9, so it makes more sense to write it under one radical. 27a over 3a cubed. So simplify there. 27 divided by 3 is 9. 1a on top, 3 on bottom means that there's 2 on bottom. Now take the square root. Square root of 9 is 3. Square root of a squared is a. Same thing here. You can see that there's common factors. So again, you can either divide it out, but you can also write it under one radical. 15 is 5 times 3. 45 is 9 times 5. So you can see that the 9s, or the 5s, we can cross them out because they simplify to 1. Then we're left with the square root of 3 on top, the square root of 9 on bottom, which is 3. Last one. None of the radicals can be simplified anymore. Square root of 10a, square root of 15b, square root of 5ab, none of those can be simplified. But what we can do is simplify this expression by writing each one under the denominator. Now it's the same thing as far as combine them or cancel. 12 divided by 4 is 3. Now you can write this out under one square root, but you don't need to show that step. The square root of 10 divided by the square root of 5, so we can write it as the square root of 10 divided by 5, which is the square root of 2. The square root of a over the square root of a is going to cancel. And then we have the square root of b on the bottom. Same thing here. 8 divided by 4 is 2. 15 divided by 5 is 3. So that's still under the radical. The b's will cancel. There's an a left on the bottom. And we're going to talk about rationalizing denominators next. But again, keep in mind that this isn't simplified because we're going to rationalize the denominator and get the radical out of the denominator. Next page. Okay, so now we're going to talk about rationalizing the denominator. We can talk about it when there's just simple square root in the denominator, but we're also going to talk about when the denominator has part of a square root, part of it is a square root and part of it is a whole number. So the first thing we're going to talk about is conjugate pairs. Conjugate pairs are binomials that have the sign in between them, one is plus, one is minus. Such as a minus 2, a plus 2. They're conjugate pairs because the a's match, the 2's match, the signs are opposite. Three x plus 5, 3x minus 5. Conjugate pairs. 3x, 3x, 5, 5. Signs are different. 2 plus the square root of 3, 2 minus the square root of 3. So conjugate pairs, binomials, meaning two parts, and the only difference is that the signs are opposite. Remember the term conjugate pairs. It's important that you remember what that means. Next page. So we're going to simplify radicals by multiplying by the conjugate. If you go back, here we can rationalize the denominator by simply just multiplying by the square root of b, because the square root of b times the square root of b is just b in the denominator. So that's how we can rationalize when there's just a single term in the denominator. Here we could do a, square root of a over square root of a, because then we would just get a in the denominator. But now, we can't just multiply by the square root of 6. Don't write this down, because you're going to need to erase it if you do. Because if I just multiply by the square root of 6 in the denominator, I'm really distributing that, so I would get 3 square roots of 6 minus 6. Well, I still have a radical in the denominator, so it didn't help me. So what we want to do is multiply the denominator by the conjugate. What's the conjugate of 3 minus square root 6? 3 plus the square root of 6. Whatever I multiply on the bottom, I also have to multiply on the top. Otherwise, I haven't kept it the same, because now I'm really multiplying by 1. Leave your denominator as it, or your numerator, sorry, your numerator as is for the moment. Now we're going to multiply the denominators together. We're going to FOIL them out. 3 times 3 is 9. 3 times the square root of 6, 3 square root 6. Square root 6 times 3, negative, so negative 3 square root 6. Square root 6 times square root 6 is 6, and it's a minus. So what happens? The positive 3 square root of 6 and the negative 3 square root of 6 cancel each other out. And this will always happen when we multiply conjugates together, and hence why we chose it. Because the goal is to get the radical out of the denominator. So if we multiply by the conjugate of the denominator, the two middle terms will always cancel out, and therefore we won't have any radicals in our denominator. Nine minus 6 is 3. The second one, what's the conjugate of 3 minus the square root of 3? Three plus the square root of 3. Same on the top. 3 plus the square root of 3. Got to multiply by 1. 4. 3 plus the square root of 3. So in the numerator, I haven't done anything. I just multiplied it, wrote it out. In the denominator, we're going to FOIL. Three times 3 is 9. We already know that the two middle terms are going to cancel out. Just like here, we can write them out and we can cancel them. But if we made sure that we had conjugate pairs, we're going to get 3 square root of 3, negative 3 square root of 3. They're going to cancel each other out. So I can just do first, which we already did, and last. Square root of 3 times square root of 3. So it's going to be minus. Square root of 3 times square root of 3 is just 3. So we have 4, 3 plus the square root of 3, over 6. Realize that we can reduce the 4 and the 6, divide by 2. So our final answer is 2, 3 plus the square root of 3, over 3. So remember that we always need to rationalize denominators. We can never leave radicals in denominators. And we've looked at some other examples where we didn't actually finish it, but that when there's a radical in the denominator, we can simply multiply by that radical. But when it's not just a monomial in the denominator and it's a binomial, we have to multiply by the conjugate pair in order to get the radical to go away. That's it for today. See you in class.